everyone. In this video we're looking at finding the inverse of a 3 by 3 matrix, but we're using the shortcut approach. All right, so we have a matrix A giving us 1 0 4 minus 1 2 2. We have 0 minus 2 minus 3. I want to find the inverse of this matrix. We can use the shortcut approach. All right, so to find the determinant, which is absolute value of A, the shortcut approach, which has been discussed earlier on, is simply maintaining. All right, so we maintain our matrix 1 0 4 minus 1 2 2, 0 minus 2 minus 3, and then rewriting the first two columns of the matrix. All right, so we have 1 minus 1 0 0 2 minus 2. All right, then after this we multiply all the members on the leading diagonal and then minus all the members on the other diagonal. All right, so we have the leading diagonal members 1 2 minus 3 0 2 0, then we have 4 minus 1 and then 2. All right, then we have members on the other diagonal. We have this, we have that, and then we have the last one, which is 4 2 and 0. Okay, so let's do the green one first. So first one, we have 1 times 2 times minus 3 plus, then we have 0 times 2 times 0 plus 4 times minus 1 times minus 2. Then we look at, all right, so let's simplify this first. If you have to simplify this, we're going to have minus 6 plus 0 plus 8, and this is going to give us 2. All right, then we look at the blue one first, next. So we have 0 times minus 1 times minus 3 plus 1 times 2 times minus 2 plus 4 times 2 times 0. Okay, so we have here will give us 0 minus 4, then we have plus 0. Okay, so this is equal to minus 4. And so the determinant of this matrix, matrix A, will be the product, the sum of the products on the major diagonal, which is 2, minus the sum of the product on the minor diagonal, which is minus 4. So 2 minus minus 4, this is going to give us positive 6. Now this is a non-zero number, so it means that the inverse exists, and matrix A is said to be a non-singular matrix or an invertible matrix. All right, so we have determinant to be equal to 6. Let's keep that in mind. And so if we want to find the inverse, once we know the determinant, we can find the adjoint. Now there is also another way of finding the adjoint, which is also a shortcut approach. That is to rewrite our matrix. All right, so I'll do this first. I have 1 0 4 minus 1 2 2, and then I have 0 minus 2 minus 3. What we do here is to maintain or repeat the first two columns of our matrix, just like we did when we were trying to find the determinant. Right, so we repeat it. 1 minus 1 0. We have 0 2 minus 2. Now once we've done this, we once again repeat the first two rows of our matrix. Okay, the resulting matrix here. The first was to repeat the first two columns of the matrix, and then repeat the first two rows of this matrix. All right, so the first two rows 1 0 4 1 0. Then repeat the second row minus 1 2 2 minus 1 2. Okay, so after this, we cross out the first row and then cross out the first column and find the determinant of all these find determinant of all these 2 by 2 minor matrices of what is left. All right, and so we have this is equal to, we find the determinant of this 2 by 2 matrix, find the determinant of this 2 by 2 matrix, and then find the determinant of these 2 by 2 matrix. Then we move on to the second column. Find this determinant, and then we find the determinant of this and find the determinant of that. All right, so first we find the determinant of these 2 by 2 matrix, and determinant of 2 by 2 matrix is product on the leading diagonal minus product on the minor diagonal. All right, so I have 2 times minus 3, that will be minus 6, minus 2 times minus 2 will be minus 4. So minus 6 minus minus 4, that will give me minus 2. See, easy. Then we move on to the next. We find the determinant of these 2 by 2 minor matrix. All right, so we have minus 2 times 4, that will be minus 8, minus 3 times 0, that will be 0, so I have minus 8 here. Then we move on to the next. Find the determinant of this 2 by 2 matrix. 0 times 2, that will be 0, minus 4 times 2, that will be 8, so I have minus 8 here. Right, so we repeat the process. We move on to the second column. We find the determinant of this 2 by 2 matrix. All right, let me use a different color code. Find the determinant of this 2 by 2 matrix. All right, so we have 2 times 0, that will be 0, minus 3 times minus 1, that will be 3. So I have negative 3 here. All right, so we find the determinant of the next. That will be minus 3 times 1, that will be minus 3, minus 0 here, so I have minus 3. Then we find the determinant of the next. We have 4 times minus 1, that will be minus 4, minus 1 times 2, that will be 2. So minus 4 minus 2, that will give us minus 6. Then we'll move on to the last column. I have these 2. Okay, so I have minus 1 times minus 2, that will be 2. Minus 0 times 2 will be 0, so I have 2 here. Then we have 0 times 0, that will be 0, minus 1 times minus 2, minus 2. So 0 minus minus 2 will be positive 2. Then the last one, we have 1 times 2, that will be 2, minus 0 times negative 1, that will be 0. That will be 0 here. All right, so I have 2 minus 0, and that is going to give me 2. All right, so once we have this, we transpose it to get the adjoint of our matrix. So we transpose this matrix. To get the adjoint, all right, so we pick the row and change it to a column. So we have minus 2, minus 3 here, and 2. Then the second row becomes the second column, minus 8, minus 3, and 2. And then we have minus 8, minus 6, and 2. All right. Now remember that earlier on we had our determinant of the matrix to be equal to 6. All right. Now we have this to be the adjoint of our matrix. And inverse of a matrix is 1 over the determinant of the matrix times the adjoint of the matrix. So this inverse is equal to 1 over 6 times minus 2, minus 8, minus 8, minus 3, minus 3, minus 6, 2, 2, 2. And this is a scalar multiplication. So the 1 over 6 multiplies the minus 2, multiplies the 8, minus 8, multiplies the minus 8, multiplies minus 3, minus 3, minus 6, 2, 2, and 2. And that gives you the determinant of the the inverse of the 3 by 3 matrix. Okay. Now we can do the same thing in Python. All right. We simply need to input matrix. Let's call it matrix C. This is equal to Gokar.array. All right. So this has 3 rows and 3 columns. So I'm going to have 1, 2, 3. Okay, so the first is 1, 0, 4. Then the second row I have minus 1, 2, minus 1, 2, 2. Then for the third row I have 0, comma, minus 2, comma, minus 3. Alright, so with this in place, now I can find the inverse of matrix C, which is simply print, right, gocard dot learn.org, right, learn.org dot inverse of matrix C, and then we print it, and we're getting minus 0.33333. All right, and so here, if we are to simplify it, all right, if we multiply this by that, we're going to have minus 1 over 3, and that is what is giving us. Okay, so we're simplifying this. We multiply the 1 over 6 by the 2, we're getting minus 1 over 3, and that is what is giving us minus 0.333 here. Then we multiply the 1 over 6 by the minus 8, all right, and then we'll be left with 4 over 3, all right, and that is what is giving us 1.333. And here too is the same thing, but in the negative form. Sorry, negative here, negative. Right, so I have negative here over 3, and I have minus 4 over 3 again. All right, and then I move on to the second row. 1 over 6 times minus 3, that will give us minus 1 over 2, and that is what is giving us negative 0.5. All right, and then here it will be the same, minus 1 over 2, and then here will be minus 1. Right, then 1 over 6 times the last row will give us 1 over 3, 1 over 3, and 1 over 3, which is the same thing as 0.33333 after the last one. Okay.